have actually the topic related to the solutions, type of solutions, and how we will prepare different solutions with different concentration units. So let's start with the word mixture. Okay, mixture. Mixture is actually combination of two or more components. Okay, what we will call mixture is a combination of two or more components. Okay, the components might be of similar types or different types. Okay, they might be in solid state or in liquid state or in gaseous state. However, the mixture is actually the combination of two or more components. This mixture might be a homogeneous mixture or heterogeneous mixture. Okay, homogeneous mixture or heterogeneous mixture. Homogeneous mixture usually have uniform composition and properties. Okay, the type of mixture where you have uniform composition and properties of a mixture, that is called homogeneous mixture. Homogeneous means there is a one phase of the mixture and there is completely surprise of the things, of the components. Okay, then we call it uniform composition and properties. Homogeneous mixture usually has uniform composition and properties. However, heterogeneous mixture has non-uniform both composition and properties. Okay. Heterogeneous mixture are further divided into two different categories. One of them is called suspension. Okay. Another one is called polarized. Okay. We will explain, we will discuss these things later. And the homogeneous mixture of components is called solution. Okay. For today, our main topic or discussion is about the solution. Okay, we will discuss what is actually a solution, what are different types of solution, okay, and how will you make different solutions with various or different concentration units. Usually we used to use the concentration units in the laboratories. Okay, our main topic for today is the solution. We will discuss in detail about solution, a little discussion about polarized and suspension. Okay, we have solution, we have polarized, and we have suspension. At the end, we will discuss the difference between solution, polarized, and suspension. So, solution. What is actually a solution is? Solution is a homogeneous mixture of two or more components usually two components. Okay. Usually we have solution properties that is made from two components. Okay. Two components. These two components are, one of them is called solute and other one is called solvent. Okay. The component which is smaller in quantity or the component which is being dissolved, mean the component which is going to dissolve in a solvent. Other component solvent greater or larger in quantity okay. The components among components, the component which is usually we take greater or larger amount in quantity to make a solution is called solvent. Okay. These two components combine to form a homogeneous mixture that is called solution. Okay. Now we have this solute and this solvent. They have different states and they are from different states, from three different states. This solute can be a gas, a liquid or solid. Similarly, this solvent might be in a gas, in a liquid state or in solid phase. Okay. It means these two components can be gas, liquid, solid, or solid will be gas, liquid, and solid. Okay, I will discuss all these things, but our main concern for today is how to make solutions where solvent is in liquid state. Okay, we will mainly focus on the solutions where solvent will be liquid state. Okay. Now we have to differentiate now types of solution. First of all, I will discuss type of a solution based on type of a solvent. Okay. Now our main focus, main area of interest for these types of solution is the solvent. Now we have to explain different types of a solution where usually we have solvent or we have different types of solvent. Solvent, if the solvent is water or a solvent where you have other solvent other than water. Okay. The type of solution where you have water as a solvent means among the components, the component which is actually a solvent, if the solvent is water, then you call it aqueous solution. Where the solvent is water, you call it aqueous solution. For example, you have sodium chloride dissolved in water. We call it aqueous solution. If the solvent is not a water, but it might be other than water, for example, you have ethanol, acetone. If these are the solvents, if these are the solvents, then the type of solution will be called non-aqueous solution. For example, mixing of any organic compound or polymer in ethanol. Here this polymer is solute and this ethanol is solid. In this case, the sodium chloride is solute and water is solid. Because in this case you have water that is actually a solvent and has the capacity to dissolve in solute. Such type of solutions are called aqueous solution. And solutions where you have a solute which is being dissolved in a solvent which is not a water, any other organic compound which has the ability to dissolve this polymer, this solute. Such type of solutions are called non-aqueous solutions. Okay. This is the first type based on type of a solution. The type of solution which is based on type of a solvent. Okay. Based on amount of solute. Okay. Now the main focus is the amount of solute. As you know, the solution is a homogeneous mixture of two components. One of them is solute and other of them is called solvent. Okay. Now our focus is the amount of solute. If you have two different solutions and one of them has lower or smaller amount of solute than other which has greater amount of solute, then the solution which is smaller amount of solute is called dilute solution. Okay? We have two different types of solutions. One of them is called dilute solution, where you have smaller amount of solute, or here you have greater or larger amount of solute. The solution which has smaller amount of solute is called dilute solution. And the solution which has greater amount of solute is called concentrated solution. It means these two terms are relative terms. You have to explain the things relatively. Means suppose you have two different solutions and one of them has 5% sodium chloride in water and other one has 20% of sodium chloride in water. The solution which has greater quantity of solute, that will be called which one solution? Concentrated solution, provided that the volume will be equal. Okay. If you have equal volume of 20% solution and you have equal volume of 50% solution, then 50% solution will be the concentrated solution and dilute solution has smaller. Suppose you have to dissolve 20 grams of sodium chloride in 100 ml of solution with water. Mean you have to make a solution where you have 20 grams of sodium chloride and you will dissolve it and make the volume. Similarly, if you are going to dissolve 50 grams of sodium chloride in 100 ml of water. You have 50 grams of sodium chloride and 100 ml of volume of solution. In both cases you have 100 ml, but here you have 20 grams and here you have 50 grams. So this is the solution A and this is the solution B. So solution B is concentrated solution and solution A is dilute solution. Okay. In this way you can evaluate either your solution is dilute one or concentrated one. Okay. Concentrated means higher quantity of solute as compared to other. This type which we are going to discuss is the type of solution which is based on what? Based on the solution of solute in salt. Okay, here you have solute and solvent both. Now you have to discuss solute and solvent and the dissolution process, the process of being dissolved. Okay, in this way, in this category, we have three different solutions. One of them is called saturated solution. Saturated solution. Okay, the solution where you have at a fixed temperature. For this particular case, you have at a given temperature. A solution which is formed at a given temperature where you have the maximum amount of solute is dissolved in the solvent. Meaning the solution where solvent has dissolve maximum amount of solute at a given temperature, and at that temperature we are unable to dissolve more amount of solute in that solvent. Such type of solution are called saturated solution. At a given temperature, maximum amount of solute dissolved in solvent. Okay. The point is at a given temperature. Mean if you are going to dissolve something, suppose you are going to dissolve sodium chloride in water at 50 degrees Celsius. So at 50 degrees Celsius, the 100 ml, suppose 100 ml of water, you have 100 ml of water and temperature is 50 degrees Celsius. At this temperature and this volume of water, okay, the maximum amount of sodium chloride that will be dissolved, that solution is called saturated solution. Okay, and other term is the unsaturated solution. As the name indicates, here you have unsaturated solution. Means at a specific, at a given temperature, here you will have not the maximum amount less than that amount. Meaning at that temperature, solvent has the ability to dissolve more and more solute. Okay. In unsaturated solution, at given temperature, the solvent has the ability to dissolve more solute. Suppose you have 100 ml of water and temperature is 50 degrees Celsius. As you know, when you have 100 ml of temperature and temperature is 50 degrees Celsius, the sodium chloride has the 50 gram of sodium chloride can be dissolved maximum. The maximum amount of sodium chloride that is going to dissolve in 100 ml of water at 50 degrees Celsius is the, suppose it's 50 gram. Now, as type of solution where you have 100 ml of water and the temperature is 50 degrees Celsius. But you have a solution where you dissolve only 20 gram of sodium chloride, and it is before you, and you have to explain whether it is saturated or unsaturated. So that solution is called unsaturated, because we already know if the 50 gram of the solute and 100 ml of water at 50 degrees Celsius, then it has the ability to dissolve 50 grams. But now you have a solution where you have 20 grams. It means that solution has the capacity to dissolve 30 grams more of sodium chloride. So such type of solution are called unsaturated solution, where you have means at a given temperature, the solvent has the ability to dissolve more water. However, this amount of solute must be less than the amount of solute that is present in saturated solution. Now, the other part is super. Okay, this is the type of solution where you can, suppose in this case, I told you at a given temperature, suppose that was 50 degrees Celsius, and the solvent was 100 ml of water. And the supersaturated solution, for the preparation of supersaturated solution, you need 50 grams of sodium chloride at 50 degrees Celsius for 100 ml of water. If you want to supersaturated solution, then what will you do? You will change the temperature. If you vary the temperature, suppose if you vary the temperature from 50 degrees Celsius to 100 degrees Celsius. At 100 degrees Celsius, that saturated solution has the ability to dissolve more amount of solute. Okay? So supersaturated solution has larger and greater amount of solute. Okay? Greater amount of solute can be dissolved in a solvent by increasing temperature. Okay? The point is saturation. So in all cases, you have saturated solution, supersaturated and unsaturated solution. If the solution is saturated, it means this solution has no, at a given temperature, has no ability to dissolve more amount of solute. Unsaturated solution means at a given temperature, this solvent has the ability to dissolve more amount of solute. Whereas in supersaturated solution, you have to increase the temperature to increase its solubility, means increase the amount of solute to dissolve in a specific amount of solvent. You need to increase the temperature. So these are three different solution types, called saturated solution, unsaturated solution, and supersaturated solution. Okay, solution, chloride, and suspension. Okay, as I said earlier, solution is a homogeneous mixture. Okay, this is a homogeneous mixture of compounds. Whereas chlorides are the heterogeneous. Heterogeneous mixture. And similarly, suspension is also a heterogeneous mixture. Okay. It means colloids is a system which lies in between solution and suspension. Okay. Usually, in case of solution, the particle size is from 0.01 to 1 nanometer. The size that is going to dissolve in a homogeneous mixture, the particle size will be 0.01 to 1 nanometer. In this case, it should be 1 to 1000 nanometer, and in this case, it is greater than 1000 nanometer. It means in case of suspension, we have particles with bigger size as compared to colloids and solution. It means in case of solution, particles usually have smaller size. So colloids lies between solution and suspension. The particle size of the colloid is in between the particle size of solution and suspension. This is a heterogeneous system. This is also a heterogeneous system, but this is homogeneous mixture. Okay. So call it homogeneous mixture, heterogeneous, later colloids and solution. Okay. In this case, you will not be able to see the particle. You cannot see particle because size is too small. In this case, you will also not be able to see the particle size, but you will see different types of separation aspect. You can see the separation between two different physics because it is a heterogeneous system. Here you have undissolved particles. Okay. In that state suspension, you will have undissolved particles. The best example for these things, in case of solution, you have suppose sodium chloride, and you are going to dissolve sodium chloride in water. After the mixing, the solution will be in one phase, and you will not see the particles of sodium chloride. Whereas in case of suspension, the best example for the case of suspension is you will have sand, and you are going to mix sand with water, and you will see clearly the particles of sand in water. Such type of solutions are called suspension. Suppose sand in water. This is the best example of suspension. Here you have sodium chloride in water. That will be clear. Here there are some sort of turbidity. Suppose you have ice cream, okay, or milk, okay, butter, okay. These are the types of colloidal system, or you have some sort of foam, okay. These are colloidal system like gel. Here you have the particle size is much smaller than suspension. In that case, in case of solution, what you have sodium chloride and water. A main difference between suspension and chloride is in case of suspension, the both type of components can be separated easily. Okay, suppose you have sand and you have water, you are going to mix it. After some time, the sand will be settled down. Or in case of colloids, both particles, both components cannot be easily separated. The separation is a bit difficult than in case of suspension, because one more thing, if you have a system that has a colloidal type of system, in that case, after they are providing or giving some time for settle down, the particles cannot be settled down. Whereas in case of suspension, particles can be settled down. Okay, this is the main difference that you have different concentration units. When you are in the laboratory, you have to come across different types of solution. Suppose usually the unit which we are going to see, which we are going to work with in the laboratory, that is a molar solution. So the concentration unit related to the molar is called the molarity. Another one is the percent solution. In percent solution, 5% sodium chloride, 6% sodium chloride, and the most important one, which you usually have to see on any juice bottle, or suppose Nestle water drinking bottle. In that bottle you usually have a badge, a sticker where you can see here you have 100 ppm, this one, this one, this one. You will see amount of some metals in ppm, that is called parts per million. Okay, here we have concentration units. Okay, concentration units, the units which you need to explain the concentration of a solution. Concentration means the main focus is with the quantity of solute. Okay, concentration units. Concentration means the amount of solute in solvent. From that point of view, you are going to actually explain the concentration. Number of moles of solute in volume of solution. Okay, or volume of the solvent, or mass of the solvent. Okay, such type of presentation is called concentration units. Okay, the first one is percent solution. We write percent solution. Okay, these percent solution are of mass over mass, mass over volume, or volume over volume. Okay, it depends upon the type of or state of solute and solvent. If both solute and solvent are in solid phase, you usually need to take mass of solute and mass of solvent. Then you will be able to find the mass of solution. Here you have mass of solute, volume of solution. Here you have volume of solute and volume of solution. Here you have to write percent. Okay, it means mass over mass percent, mass over volume percent, weight volume over volume. Okay, percent solution is actually whenever you have explain the percent solution, it is actually a mass of solute or mass of solute plus mass of solvent multiplied. In this way, you will be able to determine the concentration of solution in percent. Okay. Suppose I want to prepare 5% sodium chloride solution in water. Okay. What actually, how will I prepare in the laboratory? 5% sodium. 5% sodium chloride means you have 5 grams of sodium chloride and in 100 grams of solution. Okay, 100 grams of solution. Solution means solute plus salt. Then how will you actually prepare in the laboratory? What you will do? Or you have to weigh 5 grams of sodium chloride, and you will pour over here 5 grams sodium chloride. Okay, then you will add small quantity of water. Once you add the quantity of water, then you need to dissolve it. You have to stir it for some time. After doing solution, you will have to make the mass of the solution equal to 100 grams. Okay, you will have to add water until you will have the weight of the solution equal to 100 grams. In such way, you will be able to prepare weight by weight percent of solution. Okay, 5% solution. what will be the percentage of solution if you are going to dissolve 5 gram of sodium chloride in 98 gram of water. ओके, आपने ये बताना है कि इस सॉल्यूशन की परसेंटेज क्या होगी जब आप 5 ग्राम सोडियम क्लोराइड और 98 ग्राम वाटर dissolve. And how will you do? This is a 5 gram, this is your solute, this is 90 gram of salt. Percent of solution. How will you find 5 gram sodium chloride? You have 5 plus 98. Okay, it will be equal to 5 gram over 98. 1 gram multiplied by 100. In this way, you will be able to find the percent of solution. It means the solution which will be prepared after dissolving 5 grams of sodium chloride and 8 grams of water, the percent of solution will be equal to this percent. Okay, that's the mole fraction. As the name indicates, this is actually a fraction and fraction of moles. Okay, what you need to do actually, you have solute and solvent. What will you do? You will find the number of moles of solute and number of moles of solvent. Okay, and you know that how will you find the number of moles of solute and number of moles of solvent? As we know, number of moles is equal to mass or molar mass, meaning the given mass of the solute or molar mass of the solute. You will be able to find the number of moles of solute. And similar way, mass of solvent or molar mass of solvent, you will be able to find the number of moles of solvent. Okay, solvent. Now this is actually a ratio. If you want to find the mole fraction of solvent, then what will you do? X solvent, mole fraction is denoted by X. X solvent is equal to number of moles of solvent over number of moles of solute plus number of moles of solvent. In this way, you will be able to find the mole fraction of the solvent. Similarly, mole fraction of solute will be equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent. Okay, from these equations we come up with X total mole fraction is equal to total mole fraction of solute X of solvent in mole fraction of solute plus mole fraction of solute will be equal to 1. Mole fraction of solvent plus mole fraction of solute must be equal to 1. Okay, in this way you will be able to find the mole fraction of the solvent. In the laboratory we used to do, we have a practice to present a solution in mole fraction. We have molarity. It is denoted by capital M. But actually it is molarity is equal to number of moles of solute dissolved in 1 liter of solution. Okay. The condition is 1 liter of solution. Solution means solute and some both common. Okay, mean you have to take number of moles of solute and you have to dissolve that number of moles of solute in 1 liter of solution. Okay, suppose you want to find 1 molar sodium chloride solution. You need to prepare 1 molar sodium chloride. Okay, what will you do? 1 molar sodium chloride means 1 molar of sodium chloride, and if you want to prepare 1 molar solution, it means you have to dissolve 1 mole of sodium chloride in 1 liter, that is equal to 1000 ml of solution. This will be equal to 1 mole. And how will you prepare? You will actually take a volumetric flask of 1 liter. Okay, here will be the mark that will be equal to 1 liter in 1000 ml. What will you do? Actually, you are going to prepare 1 molar solution. In the laboratory, how will you weigh the moles? And you have already this concept that 1 mole of sodium chloride is equal to 58.5 grams. Okay, this is molar. This is equal to 1 mole. And here you have to find 1 molar. It means 1 molar means 1 mole divided by 1000 ml of solution. 1 mole is equal to 58.5 grams. What will you do? You will take the sodium chloride and go to the weighing box, weighing balance. Okay. From that balance, you will measure 58.5 or weigh 58.5 grams of sodium chloride and then pour it into 58.5 grams sodium. Then you will add small quantity of water. Okay. Then you have to stir it for some time. Once you feel that this sodium chloride has been dissolved in that amount of water, then what will you do? You will fill this bottle, volumetric flask, up till this mark. Because this volumetric flask has the quantity to have, has the ability to manage 1 liter of for solution. Okay. Once you fill it, then you will need to know this mark. Okay. This volumetric flask must be filled up to this level. Okay. Now this solution will be the 1 molar solution. If you want to make 2 molar solution of sodium chloride, and what will you do? You will take 2 moles of sodium chloride and you need to stir it small quantity of water for some time. Once you feel it has been dissolved, then you will make the volume up to this mark, and that solution will be equal to 2. What will you do again? You need to take 2 moles of sodium chloride and 1 liter of such type of solutions are called molar solution. Another term that is called ppm. We used to write in this way or in this way. This is actually parts per liter. It means 1 ppm means 1 part from the millions. 1 part from the million means 2 diluted solution. Okay, how will you prepare? You will take 1 milligram of solute and you have to dissolve it in 1 liter with 1000 ml of solute. This will be the 1 ppm. What will you do? You have this volumetric flask. Up to this, its volume is 1 liter, means it has the capacity to have 1 liter of liquid in water. Okay. Now what you have to do, in previous case, you want to prepare actually 1 molar solution. And for that purpose, you measure 58.5 gram of sodium chloride to dissolve in 1 liter. But here you have 1 milligram of any solution. Suppose I will say prepare 1 ppm sodium chloride solution. It means forget about the molar mass of solution. No need to weigh the molar mass of the solution. You need to weigh only 1 milligram. Okay, 1 milligram of sodium chloride, and you have to add small quantity of water. You will stir it for some time. Once you feel it has dissolved, and what you will do, you will make the volume up to this mark, and this volume will be automatically 1 liter. Because in this 1 liter you have both solute and solvent, then this 1 liter will be called 1 liter of solution. Okay, 1 liter of solution. Because you added or you weighed 1 milligram, and we know that once you have 1 milligram of solute in 1 cup solution, such type of concentration unit is called parts per billion. And because you have dissolved 1 milligram of that solute, you call it 1 ppm solution. In the similar way, if I would say 5 ppm solution of sodium hydroxide, suppose sodium chloride, what will you do? You will measure 5 milligram and make the volume 1 liter. Suppose I will say 10 ppm of potassium nitrate. And what will you do? No need to find the molar mass. You just have to weigh 10 milligram of potassium nitrate, and you need to dissolve this small quantity of water, and after this solution you need to make the volume up to 1 liter. In this way you will be able to find or determine or prepare parts per billion solution. Strictly the point is 1 ppm is equal to 1 milligram. Suppose I will ask how will you prepare 30 ppm of sodium chloride. We will say, sir, we will take 30 milligram of sodium chloride and dissolve in 1 liter of, and we will make the solution in 1 liter. That will be equal to